All right, guys, so today we are going to start 13.2, where we talk about angles of rotation and just the different parts of these angles. So the first thing that we are going to talk about when we're talking about angles is the standard position of angles in a coordinate plane. So the standard position is going to be when we have an angle with the vertex at the origin and a ray on the positive x-axis. So what that's going to look like is a ray or an angle in standard position. We're going to start with our vertex at the origin. We have one ray that's going to be on our x-axis. And then we're going to have the other ray of our angle can really be anywhere. So I'm going to say I have a ray that's going to come out like this. So this angle that's created, that is going to be an angle in standard position. So when we have this, the side that's along that x-axis, we're going to call that our initial side. And this side that is not along the axis, that's going to be our terminal side. Okay, so the next thing that we're going to talk about is coterminal angles. So think about if this is our terminal side, and we're thinking about what that prefix co means. So the coterminal angles are going to be the two angles that we can use these rays to kind of identify. Excuse me. So when we have a positive coterminal angle, that's going to be when we're going counterclockwise. So if I'm using these two rays, my positive coterminal angle is going to be this angle created right here. So if I said this was a 75-degree angle, my negative coterminal angle is when I'm going clockwise. So think about if this small piece is 75 degrees, what would the angle of this larger piece have to be? Well, all the way around would be 360. So I would do 360 minus 75. So this would be 285 degrees. But since I'm going clockwise, it's going to be a negative 285 degrees. So just to kind of define this like coterminal angles idea, it's just any two angles with the same terminal side. So since both of these, the 75 and the negative 285, both share a terminal side here, those are going to be two coterminal angles. Okay, the next idea that we're going to look at is this idea of a reference angle. So I'm going to just draw a new angle here. I'm just going to draw it out this way. It doesn't really matter where you guys draw it. This is just where I picked to. So a reference angle is going to be the acute angle formed by the terminal side. Let's rewrite that. And the x-axis. So notice how in this one we just say the x-axis, and in the standard position we said the positive x-axis. So the main difference here is when we have something in standard position, we always want to be going kind of towards that infinity on our x-axis. Where in a reference angle, we're just looking at the angle formed by our terminal side and any part of that x-axis, positive or negative. So this red one here, this is going to represent our reference angle. And we're going to use this a little bit later today and show kind of how reference angles can be used and can be helpful. So these are all of the definition pieces that we want to be able to identify. We have our initial side, our terminal side, our coterminal angles, and our reference angle. So what I want to do here is I want to do the first three together. And by the first three, I'm going to go column. So I'm actually going to do 1, 4, and 7 with you guys. And then I want you guys to pause the video and try the other 6 on your own. And then we're going to keep going on to the next page for today. So first thing is draw the following angles in standard position. Then we want to find 2 coterminal angles. And then we want to find the reference angle. So we're going to look at all 3 of the pieces from above. So the first thing that I'm going to do here is I'm going to just change my color really quick. And I'm going to draw each one of these. Just kind of give them that coordinate plane. And then just like I picked for the colors above, I'm just going to do the same colors down here. So standard position is going to be in blue. So 77 degrees in standard position. So thinking about how this coordinate plane would work with degrees, I'm thinking, okay, this would be my 0. This would be 90 degrees. This would be 180 degrees. And this would be 270 degrees. So if I want something that's 77 degrees, oh, I'm sorry guys. I'm going to draw something in this first quadrant that's a little bit more than halfway. So I'm going to draw an angle that looks like this. And then I also have my other side that's going to be along the axis. So I know that this right here, and I'm going to draw it kind of big so that we could fit everything on here. This is a 77 degree angle. All right, the next thing it asks us is for 2 coterminal angles. So coterminal, we're looking at those positive and negative values. So I'm going to go to green for my 2 coterminal. So the first is if I start up that initial side, I go to my terminal side, going counterclockwise. That's going to give me the same 77 degree angle. And since I'm going clockwise, that's going to be positive. Or since I'm going counterclockwise, I'm sorry. So my co-terminal angle, the other angle, I'm going to start again at my initial side, but now I'm going to go clockwise around my terminal side. And I'm thinking, okay, so if going counterclockwise was 77 degrees, and all the way around would be 360 degrees. To find the other angle, I would do 360 minus 77, which is 103. That's not right. Hold on. I have it written down here in my notes, but that's definitely not right. So 360 minus 77 is 283. And since I'm going clockwise, it's going to be a negative 283 degree angle. All right, the very last piece that I'm looking for is that reference angle, which I'm going to do in red. So the reference angle is just that acute angle made by my terminal side and the x-axis. So I'm just going to go straight down to my x-axis. Well, it's still just that 77 degree angle that we started with. Awesome job, guys. All right, so let's go ahead and do this next piece. So first, we want to draw in standard position. So I know I'm going to have something along my x-axis, negative 45 degrees. So we said negative is going to go clockwise. So I'm going to go clockwise 45 degrees, which would be directly in the middle of this piece. So this is my negative 45 degree angle. And again, we still have that 0, 90, 180, 270, and this 0 is also our 360. Okay, so we did our standard position. So let's find our co-terminal angles. So first I start at my initial side and I want to go counterclockwise around to my terminal side. So I'm thinking 360 degrees. I know that this is a 45 degree angle. So if I subtract, I'm going to get 315 degrees. Since I'm going counterclockwise, that's positive. Then I'm going to start at my initial side. I'm going to go counterclockwise, and that's going to be my negative 45 degrees. And the last one that we have is that reference angle. So I start at my terminal side, and I go to the x-axis. So that's going to be a 45 degree angle. So this one is going to be a little bit different. So with reference angles, we want to keep in mind that reference angles, we're always going to have those be positive. So even if we were to go counterclockwise or clockwise, either direction, we're going to consider that a positive angle. All right, last one together, and then I'm going to let you guys do the rest on your own. So first thing is a 270 degree angle. So if this is 0, 90, 180, 270, and 360, I'm going to have my initial side be on the x-axis, and then my 270-degree angle be straight down. When I do my co-terminal angles, I'm going to start on my initial side, and I'm going to go counterclockwise first. And that's going to be a 270-degree angle. Then if I start on my initial side and I go clockwise, that's going to be a negative 90-degree angle. And then if I look at my reference angle, it said the acute angle formed by the terminal side and the x-axis. Well, if I think about it here, if I take my terminal side and I go to my x-axis, that's going to be a 90-degree angle. So going clockwise didn't get me an acute angle. So if I try counterclockwise, that's still going to give me 90 degrees. That's still not an acute angle. So here, we're going to really say that we don't have a true reference angle. Since it's not acute. These ones are not reference angles since it's not acute. All right, guys, so go ahead and pause, try these next 6 on your own, and then we will come back together. All right, so hopefully you guys got answers that match what I have here. I think the 2 trickiest ones here were going to be 8 and 9, so I want to kind of take a second just to talk about those 2. So in number 8 and in number 9, we had 2 angles that were greater than 360 degrees. So when that happens, I want you guys to kind of take a look at what I did here with my 400 degrees. We still start on that initial side, but what we're going to do is we are going to make a complete circle and a little bit more to actually create that angle. So it really looks the same as a 40-degree angle that we would have to see here. So when I'm looking at coterminal angles, I could look at my 40 degrees and my negative 320 degrees. And when I'm looking at my reference angle, I could look at just that 40-degree angle. And similarly with number 9, you would start on that initial side and you would go 360 degrees, and then you would go the rest of the way, which actually hits on the other side of the x-axis. So when I'm looking at my coterminal angles, I can still start at that initial side and just go until I hit the first time around. And I hit that 180 degrees, and then go the opposite direction and get the negative 180 degrees. The other interesting thing with this one is that we don't have a reference angle because 0 degrees is not included in our acute angles. So remember, acute means between 0 and 90. So not including 0 or 90. All right, so go ahead and let's flip the page. And we are going to use some of these ideas to find the exact value of the 6 trig functions. Okay, so for number 10 here, the first thing is it says, if P is a point on the terminal side of theta in standard position, find the exact value of the 6 trig functions. So what I want to do first is I want to plot this point, negative 3, 4. And then I'm going to go ahead and draw in that angle in standard position. And so now what I want to look at is I want to find the value of my 6 trig functions. So I'm going to have sine, cosine, tangent, and then their reciprocal ratios of cosecant, secant, and cotangent. And so when I'm looking at those, we're thinking theta in standard position would be this angle created here. But if I'm wanting to find the value of the 6 trig functions, what I'm really going to look at, and I'm going to zoom in on this image, is I'm going to look at the right triangle that's created right here. So I'm going to look at using this angle, using that reference angle that we have, so from the terminal side down to the x-axis, to help me solve these trig functions. So if I look at this right triangle, my bottom side is -3. My height is 4. And so my hypotenuse, that's actually one of the Pythagorean triplets, 3, 4. So I know my hypotenuse is going to be 5. If you don't believe me, you are more than welcome to check. So I'm wanting to look at what is the sine of this new little theta value here. So the sine is, I'm going to write my SOHCAHTOA up here just so that we don't forget it. SOHCAHTOA, sine is opposite over hypotenuse. So I'm going to have my 4/5. The cosine is adjacent over hypotenuse, so -3/5. Tangent is opposite over adjacent, so 4/-3. And then, and this is again of my theta, and I'm just going to write theta in for all of these. My cosecant, that's the reciprocal of my sine. So instead of opposite over hypotenuse, I'm going to do my hypotenuse over my opposite. Secant is the reciprocal of cosine. So instead of adjacent over hypotenuse, I'm going to do hypotenuse over my adjacent. And cotangent, instead of opposite over adjacent, I am going to do adjacent over opposite. So there we go. We have all 6 of our trig functions. And then we're going to go ahead and skip number 11. I want to give you guys just the rest of the time today. Work on that worksheet on Google Classroom. Make sure to turn it in. And I will talk to you guys tomorrow. Have a good rest of your day. Let me know if you have any questions.